Hello, my natural born scientist. In this second part video, I'm going to be explaining the amazing application triangle and life's ability to live in extreme volcanic heat and extreme Arctic cold. Hi, if you don't know me already, my name is Eduardo Hernandez, aka Trisapient. I'll be giving a series of videos, so please subscribe or comment on these videos. During the process of these videos, I'll be explaining my theory, emergent chemical evolution, and the different parts of it. I'm making these series of videos to explain the different parts of the theory, which is many, and that's why I wrote a book, and it's available on Amazon and anywhere ebooks and regular books are sold. Well, let's get started with the video. As I explained before, there are many sources of amino acids, both from space and terrestrial, that can cause, and reasons for them here on this side of this triangle to make them polyamino acids. Now, I mistakenly claimed that abiogenesis would start here, but no. After reviewing this this setup, for better explain why polyamino acids are better and how life uses them from extreme volcanic heat to extreme Arctic cold, I discovered that no, life wouldn't start here. Life can start anywhere in this range in extreme volcanic heat, depending on the arrangement of the amino acids. The amino acids, the difference between life using amino acids up here and the amino acids that life uses down here is strictly their arrangement. Only their arrangement. It's not that the life down here in extreme cold uses different amino acids. It uses the same amino acids. What's different is the way they're arranged. The same protein that does the job here at low temperatures cannot do the job in extreme temperatures of heat, but the difference in those two proteins, the one that does in extreme heat and the one that does in extreme cold, is nothing more than the arrangement of the amino acids. The shape of the proteins is actually extremely similar. The only difference between the proteins up here and the protein down there is a 45% difference in sequence, meaning the amino acids that are up here, the arrangement and location of those amino acids are 45% different than the arrangement they have down here at low temperatures. So what that tells me is that there's nothing chemically different of the amino acids being used up here and the amino acids down here. What makes all the difference in the amino acid sequence is that they need to be placed in different positions, but all in the same shape. So what it is that certain shapes, in order to maintain the shape, a certain sequence has to be provided by those amino acids to maintain that shape at high temperature, and a different sequence of amino acids needs to be placed for that shape to maintain its shape in that sequence, for that shape to be maintained in cold temperature. So what that means is that there's a whole range of sequences that amino acids can take to maintain the same shape, but so they can maintain the same shape in different temperatures as well as different pH. And here's the other thing. The pH mostly determines how well bound a protein is, so that a protein at a certain pH, if it's not at the right temperature, will not work. If it's also not at the same, if it's at the right temperature but it's not at the proper pH, it will not also work. So you have a variety of sequences for these proteins to take the same shape in high temperature, different pH, low temperature, different pH, and everywhere in between. 45%. You understand what that means? 45% sequence difference. That means that it's a 50-50 chance that you can manage to get the proper sequence to work this shape out. You understand? The way proteins work is they're repeating structures that any sequence of amino acids will create. They don't have to be in a specific sequence to make those alpha helixes or beta sheets. It's the combination of alpha helixes and beta sheets that make the reactive centers for these proteins. It's not specifically the sequence. Of course, within that sequence, the active amino acids have to fall within that active region. But the rest of the amino acids can be any type of sequence as long as they create alpha helixes or beta sheets, and it's the proper pH and the proper temperature, then that protein will coalesce and form the shape needed to catalyze those reactions. So what this shows me is that there is a variety of an unsurmountable amount of sequences that can be made of amino acids that can work from high temperature to low temperature. So what that tells me is that I mistakenly put here that abiogenesis started here. No. Abiogenesis could have started a number of times in any of those locations of high temperature, medium temperature, perfect temperature, low temperature. All those different areas could have given the emergence of life. Life could emerge anywhere in those. Once life started, it could also evolve to fit any of those environments. So what the great thing about amino acids is that this molecule can work in any environment. It does not need to be in any specific sequence or in any specific conditions, like all these other theories postulate that it had to desiccate and form in volcanic vents or in the interface between the atmosphere and the water, or on the surface of surfaces of minerals on rocks. No. Life needs water, whatever temperature and whatever pH. What it does need is carbon dioxide to make those pHs. And of course it needs carbon. Carbon is the only atom that can form these molecules that make amino acids that can do all this work in any of those conditions. So life could have very easily started with multiple sequences of amino acids, which polyamino acids are created in any variety of way. It rains down. It still does to this day rain down from outer space. Every year we get 40 tons of organic material falling from space. So, there's absolutely no reason to look anywhere else except that amino acids for the origin of life. And my theory explains step by step how that could have occurred, and the evidence of modern experiments showing that this is a very, very possible scenario. I personally think it's the only possible scenario. And with all the evidence that I keep coming across day after day, it seems irrefutable, in my opinion, that emergent chemical evolution was the way that abiogenesis started, with amino acids producing RNA, and then RNA, a system of replication, did not take over. It took over storing information and worked with amino acids to start life. It's not either or. Life has never worked that way. Life always works in conjunction. Multiple systems, multiple molecules, you know, it works in multiple physical systems within this planet. So I don't understand why we need to see abiogenesis starting from one simple system, in one one simple set of conditions and simple molecules that have nothing to do with life. So please subscribe, take a look at my book, and please comment below. Any criticism is welcome. If my theory cannot hold up, I'll abandon it. I challenge you to find any fault. Once you read my book, you know, just these videos is not going to be enough information for you to do that. But please, I welcome all criticism, and of course any compliments. But please enjoy these videos. I'm having a great time making them. Bye.